Hi, welcome to my talk, the next generation observability, looking at Kong and artificial intelligence. So just to start off my talk, I'm just going to run through a quick agenda. I'm going to introduce myself a little bit, just talk about me and my experience. I'm going to talk a bit about the business costs and what it looks like with slow troubleshooting practices. Talk a bit about current observability and the challenges that businesses are starting to see with their observability stacks. Then discuss the pros and cons of large language models and how impactful they can be. Then how using these two tools together and how it's showing some promise. I'm then going to jump into a demo, show you the usage of the two together, and then summarize at the end everything that we've just spoken about. So my name is Andrew Q. I'm the co-founder and CTO of Quadcore. We're a software consultancy working in the UK in the API and microservices industry. I also like working within the open source community. So I'm a maintainer of the Prometheus operator Helm chart. I'm also a very proud Kong champion and have worked with Kong for the last 2 years on a residency program, helping a lot of their large enterprise companies design and deploy Kong, as well as the Kubernetes ecosystem and cloud infrastructure, taking them from either zero to production, or if they've already got something built, just helping them improve it to get it to a good state for production. I've also contributed to a number of other Helm charts through the open source community. I'm sure these are a number of charts that many of you have used, but pretty proud to have contributed to the Kong products as well as their Helm chart. So over the last 2 years, I have worked across a number of different companies' production sites. As already mentioned, I've helped a number of businesses, some large enterprise, some a bit smaller, get their architectures into production and be production ready. And I've seen, different deployments. It could be either different Kubernetes deployments, or it could be different cloud architectures. Every company has their own architectures, their own tools that they're like using. But a very common trend that I've seen with all of them is around the observability and the observability deployments that they have. Most companies have very large and complex architectures, especially with the move into the Kubernetes space, microservices, distributed services, and each of these layers gets to the point where they all generate a lot of observability data. We're getting to the point now where a lot of the companies are now adding API gateways to the mix, ensuring that they are managing their policies in a centralized manner. But this additional layer is adding to the complexity of their architectures. And with this increase in complexity and increase of additional layers, I think introduces the challenges for troubleshooting issues. So what is the current business cost? What does it look like as a business cost for high mean time to resolution? For a business, the cost for slowly resolving issues is not always directly financial. Taking an example of an e-commerce company, the reputation of the company when you are struggling to get your systems back up and running again can almost be more impactful to the company than just a financial cost. When your systems are down for an extended period of time, you could have consumers or customers actually starting to move across to competitors' services. Resolving a reputational damage is actually very difficult, almost more difficult than any other damage. So, taking this into account, the most obvious cost for a high mean time to resolution is going to be your financial costs as well. So, how can we resolve this, and what can we take into account to do this? Well, obviously, observability has always been the go-to mechanism for companies to resolve their high mean time to resolutions. Observability has built on three pillars: metrics, logs, and distributed tracing. And each of these bits of information gives you the view as to what's going on in your systems. But as mentioned before, as architectures are getting more and more complex with more and more layers, each of these layers are generating their own set of metrics. And what we're getting to is a point where the observability metrics are vast, and there's so much information that actually, as an engineer, being able to analyze and process and look through all this information is becoming harder and harder. What I've seen at multiple customers as well is dispersed data, so observability tools that aren't necessarily linked together. And this then adds to the complexity. Engineers will need to look into multiple different tools to be able to analyze the data when things go wrong. And I think the switching between tools and trying to find a link between the data is becoming very slow and very error prone when done by hand. So effectively, how impactful can AI be? So AI has been a very hot topic over the last sort of 18 months or so, especially large language models. But I think to understand how impactful these can be to yourselves, we need to actually have a look and compare a little bit of the pros and cons between AI and large language models. The reasons why we need to do this: it is still a very new technology, and I think not taking into account some of the limitations would be doing the technology a disservice. It is still very new and has some sort of a way to go, but I think is showing some very powerful promise at the moment. So the first strengths and limitations I think we can compare, which I've spoken about already, is about the processing of vast amounts of data versus the limitation of the token size. So, being a automated model, being AI, it can process a lot of data very quickly, and data from different sources as well. It doesn't matter, how many different systems you've got where the data is, you'll be able to pull all of that in and actually be able to analyze all of it. But the limitation there is around the token size. So the token size is the amount of data that you can send to an AI model, to an LLM, and then the data that it can send back to you as well. So the size of this token is actually dependent on the model that you are running. There are a number of different models that you can, and I've seen the size ranging from 8K to about 32K with the current GPT-4 model that I've seen deployed. So I think it's important to understand, although currently the model, the large language models can process a lot of data, you can't just send it everything. You actually need to understand and ensure that you're only sending the relevant information, the context for the issue that you're currently looking at, and then it will be able to process that and have a look. I'm sure things will move on over the next couple of years, but right now, a limitation that I think is worth taking into account. Next, having a look at scalability versus bias. I think the one really nice thing with large language models is that you don't have to create a specialized model for every task. A single well-trained large language model can actually be adapted for different tasks, and you can use it as sort of a generalized capability to save time and resource. Actually, retraining a model is very resource and time intensive and quite costly as well. So having this sort of generalized model that can work with a number of different use cases is quite a positive strength for the large language models. But I think one thing you have to take into account is the bias of the model as well. And unfortunately, it can inadvertently produce misinformation. The models are only as good as the data they're trained on. So if it's been trained on data that has bias or has errors, unfortunately, the model will end up amplifying those biases. And there's a term that's being used currently within AI, and that's hallucinations. So what you can get is models hallucinating and generating data or a response that you get back from the model that effectively isn't true. And it's maybe some data that the model has hallucinated and in a way made up. So something that's very important to understand when using these models. The next strength to have a look at is the human-like interaction versus the lack of deep understanding. The one really great thing about large language models is they can understand and generate text in a very human-like manner, which is really nice for certain use cases. It makes them very suitable for tools such as or use cases such as chatbots or personal assistants. Or sort of customer service bots. But I think the one thing to really take note is despite they seem like very sophisticated technologies, it doesn't truly understand the content that it is looking at and the content that it is analyzing. It's predicting a response based on the patterns observed within the training data. It doesn't really understand the information that it is sending you. And I think this kind of maps really nicely into the hallucination weakness that I spoke about, or limitation that I spoke about in the previous slide. So, other than that, taking that all into account, I think, using these two tools together, so your, full stack observability and large language models as part of an AI capability, I think are quite perfectly matched. Talking about the different use cases that you can use, I think these two together are actually showing some very huge promise. And taking into obviously the considerations that I've just mentioned before, these tools will be getting better and better as the technology becomes more mature. But right now, I think it can be still very powerful and is showing some really great promise. So taking that into account, I'm now going to jump into a bit of a demo and actually show you the usage of large language models, AI, with observability. So just quickly to talk through what I'm going to demo before I start the demo itself. So I'm going to be using a tool called Robusta. Robusta is effectively an observability tool that doesn't replace your current observability, but actually runs as a layer on top of your existing observability data. So don't think that it would be replacing it, but instead it would be a single pane of glass that goes across all of your observability tools, all of your monitoring data, and it has the ability to be able to pull all of that data and analyze it. So getting that single pane of glass, it then is a really great tool that you can use to investigate when there are issues. It gives you the ability to investigate when alerts are fired and allowing you to enrich those alerts with additional data, which can obviously help you to improve your troubleshooting whenever you have issues within your architecture. It also has the ability to check the configuration of your cluster and actually analyze that. And it's a really great tool to make sure that you have configured everything correctly and that there aren't any issues. And as things change, you obviously can still re-scan your clusters and check whether there are any changes and anything that you can improve on. And I think almost one of the best parts of it is the developer self-service. It gives the developers or engineers the ability to be able to come to this tool, single location for them to be able to get the information about all their services and be able to self-service themselves rather than there being this, bottleneck on the platform team when there's any issues with the platform. The engineers and developers can come to this tool, Robusta, and they can actually find out what is going on before they just default to go to the platform team when there's an issue. So a very quick look into the UI. This is just a quick snapshot of the UI. You know, down the side you can see all your applications, a nice timeline which shows changes within your cluster. You can have a look at your jobs, your nodes, even the clusters, just having a look at how the clusters are doing. And then at the bottom, the efficiencies and best practices. So that's having a look at the configurations of your clusters and just ensuring that everything is configured as it needs to be. So what Robusta has then done is taken it one step further and integrated AI into the platform. This currently is a beta feature that I have had the pleasure of getting my hands on. But what they've done is they've linked their single pane of glass to an Azure OpenAI service to give you the ability to get this AI assistant and the ability to investigate your troubles. You know, and if you think about it, Robusta is that single pane of glass that gets your observability data from, you know, all of your tools, that aggregation, that single location, and then it's able to take that information and pass it on to Azure OpenAI. Why Azure OpenAI? Well, it gives you that, you know, security of all of your business data is secure and not going to a public model like any of the public deployments. So that just gives you that security around all of your IP and data within the organization. This, in my mind, gives you an even better self-service for your users. Not only is it just your engineers, maybe even your platform team, but the capability can now be rolled out to even a networking team or your NOC team. So I think, you know, this addition, this new feature that they are releasing adds to the self-service of the platform. A very quick look as to what that looks like. You know, gives you at the layer of your application the ability to click an AI analyze button where it will reach out to Azure OpenAI, and then you will get back some information based on all of the data that it sends across to you. So having a look at my stack, the use case that I'm having a look at here is a company with two teams, an API team and a payments team. The API team owns the API themselves. They built it, they own it, but they are using the payments team service. So a service that is out of their control, but their API is consuming that. A very common use case in larger companies where you've got sort of teams that are owning their own portions, their own services within the company, maybe a business unit or a team, and having this dependency between these teams and business units. I'm using Kong Connect, which is a SaaS offering from Kong, to configure my Kong gateways. And I've got a runtime group for each of the teams, which we'll have a look at in a second. My services as well as my Kong gateways are all running on Kubernetes. I'm then using Prometheus as my metrics, my observability metrics tool. Jaeger is my distributed tracing tool. And as mentioned before, Azure OpenAI as the large language model with a GPT-4 32K-bit deployment model being used in Azure OpenAI. So what am I going to demo? Effectively, the payments service is going to be making a change. So the payments team have decided that they're going to change the port that their service is running on. Our API is then going to start throwing errors. So it's actually going to end up with some timeouts because it can't access that service anymore. We're going to go across to Robusta and have a look and see what the problems are and see if we can identify anything. Robusta is going to take all the information from Kubernetes. That's with regards to, you know, changes in the cluster, the logs from the pods. I'm going to take metrics from Prometheus, the traces from Jaeger, and we're going to pass all of that across to the Azure OpenAI service, and that's going to return and give us hopefully some information around what's gone on, and hopefully an indication as to what we need to do, or where we need to go, who we need to talk to start resolving this issue. So that is now the start of the demo. What I'm going to do is just switch across to Connect. This is the UI for Kong Connect. And as you can see, I have got two runtime groups, the API team and the payments team. Quickly jumping into the API runtime group, I've got one gateway running on Kong 3.4, and I've got one service, just the API service, calling my Kubernetes API service pod. In the plugins, I'm running the OpenTelemetry plugin, pushing data to Jaeger, and using an upstream timeout plugin as well, just so we're not spending too long waiting for the response to come back. Looking at the payments team runtime group, again, I've got a single payments gateway running on Kong 3.4. And I've got two services, the payment service and the currency service. And again, two plugins, same as the previous runtime group, the OpenTelemetry and the upstream timeout. So just switching across and having a look, what I'm going to do now is I'm effectively going to make a call to my API. So making a call to my API, you can see I've got a response, and just looking at the headers, I've come back with a 200 response. And as you can see from here, I'm running on Kong 3.4 with very minimal latencies as well. So very quick response time, which is what we would want. What I'm now going to do is I'm going to make a change to the payment service. So make that change. And effectively, as mentioned before, that was a change to the ports. So let's jump across to Robusta and have a look at that change. So jumping into Robusta, I'm going to go into the payment service and just have a look at the last 15 minutes. And you can see here, there's a change. When I open that and have a look, you can see what's happened here is I've changed my port from 1990 to 1991. So the payments team have decided they've changed the port number that this service is currently running on. A really nice feature of Robusta, the ability to get this delta of the changes within your cluster and being able to see them on the timeline, which I think is a really great part of the tool. So coming back to our command line here, what I'm going to do is make another call to the API. So making the call, and now you can see, based on the last request that I made, it came back within, sort of a few milliseconds or seconds. And now this is taking quite a lot longer. So I've got the timeout set on the upstreams in the in Kong Connect. So this will come back any second now. But, this is simulating the issue of the API now throwing in an error, I guess, in a way. And now that it's come back, you can see we've got a 504 gateway timeout. And you can see that Kong has come back with an upstream server is timed out. And actually having a look at these latencies now, they are a lot larger than they were before. These are in milliseconds. So a lot bigger than before. So, now to start troubleshooting this, let's jump into Robusta and go to the API server. So I'm, now got the hat on as the API team, and I'm coming in and I'm going to start having a look at my own service. So just looking at the last 15 minutes and having a look at it. And from here, you can see that there's actually nothing has changed. The timeline is showing no change to my service. So we haven't as a team changed anything. And most of the resources are looking pretty good here. I've got a ready state as well for this particular service. So in our mind, they shouldn't have this delay and this error that we've got. So let's jump in and actually run this AI analyzer. So running the AI analyzer, what this is now doing is it's taking all of that observability data I spoke about, the changes to the cluster, the pod logs. It's taking the Jaeger the Jaeger traces and passing that to Azure OpenAI. And now what you can see is it's coming back with a response that it's now analyzed a lot of this data. And just having a look at it quickly, it's saying there seems to be a problem with the upstream service. The application is trying to access the payment service, which you can see there, but it's getting a 504, which we saw, which is a gateway timeout. And this is evident in the pod's logs. So in the pod logs, it's actually found that there's an issue. There's a 504 instead of a 200. It also now is looking at the Jaeger traces. So, also the Jaeger traces are showing that a 504 is coming back for that exact same service. And finally, some recent changes have been made to the cluster when the payment service has been updated. So, this has now gone and, the AI has effectively found 3 points of data. It's found the pod logs, it's found the Jaeger traces, and it's found the delta, the changes within the cluster. And effectively what it's saying is it looks like the payment service could be where the problem is. It's effectively saying, these could potentially be why you're having an issue. Further investigation would need to be done to confirm this. But looking into the payment service and reviewing the changes is what you would need to do. So as the AI team, what I can now do is go, okay, well, we need to contact the payment service. And they can then go to that team and say, here is our analysis. Here's the data that we found. These 3 points of data point towards something that you've just recently changed. Can you have a look at it? And then you can resolve it as quick as possible. So that effectively is the demo. So just to summarize everything that I've now spoken about, what I've looked into is we looked into the current full stack observability and what that is started to look like today. I think as architectures have got more and more complex, as there are more and more layers that have been introduced, what we are getting to is a point where vast amounts of data is being generated, and actually the analysis of this data is becoming more and more error prone, as well as very slow. And I think finding any connection between the data is just becoming more and more difficult. With large language models being this new technology that has been introduced, I think it's being used in the right way can be very powerful. It's very fast and obviously automatic, and it has the ability to analyze lots of data and actually find trends and links between this data. So I think the marriage of these two technologies has huge potentials. As already mentioned, it's still a very new technology. It still has a way to go, but in my opinion, it's actually showing some huge promise. And using it as what I would coin the term next generation observability, using it as a single pane of glass to be able to link trends between multiple different data sets, I think is where observability will be going, and is definitely a space worth keeping your eye on. So that concludes my talk today about next generation observability. If you would like to reach out to myself and discuss this topic in any more detail, or just reach out to me to just talk about anything, I've got my email address on the screen now, as well as my link to LinkedIn. Please reach out to me. I'm more than happy to discuss this with you. Thank you very much for your time today. Enjoy the rest of your day.